So I think the first thing is it needs to be something that can be operated without electrical power, only using power sources such as manual power that are available in any neighborhood. That would be the first point. The second point is that it needs to be able to be collapsible so that it can be transported on a truck. Remember, the main problem we have is that the waste takes up too much space, too much volume on the truck. If we then have a compactor that takes up a lot of the space itself, it's kind of defeating its own purpose. And I think the third aspect, which is very important, is that it's made of locally available materials. Mm-hmm. This is something we've seen many times in these supposed cool technology projects that are supposed to help people in developing countries, is that they get some fund from a wealthy country, let's say from a European country, which has some very advanced technology that works in their European country, and they get maybe grant funding to put this into a developing country. And if they go there, they have a lot of experienced and expensive engineers from wealthy countries. They come and they set everything up in a laboratory environment, and it's all perfect and wonderful. And then the grant funding ends, and those expensive technicians go back home, and they leave the local company or the local operators to use the system. And they don't have stable power supply. They don't have hygienic conditions. They don't have, in particular, they don't have easy access to spare parts. And over time, the machine begins to need maintenance and spare parts, and they're not accessible or they're very expensive. And eventually the machine stops working, and then it just sits in the corner gathering dust. I've seen that so many times in projects that I've worked with in Africa, but in particular in the area of waste. So we wanted to make something that is 100% built with materials that are available in the local market in Mozambique. And from our experience, these are also available in other countries where we're beginning to operate, such as Zambia. What I'll actually do now is show you one of our small prototypes, and I'll get Arcel to explain what this is made of and where we get those materials.
Yeah.
Então, o que queremos é evidência desses materiais. Talvez isso aqui o que é chapa de ferro, de qual é 1 milímetro, né? 1 milímetro. E depois temos isto aqui, isto é arame, mas isto é arame galvanizado. E depois isto foi juntado com soldadura, né? Usando equipamentos de soldadura e eletródos. Okay. So this is one of our very early prototypes. We'll explain it a bit more later how it works, but it's really made out of all of the materials it's made of.
Yeah.
And the tools that we use to make it are locally available because of the local building trade. So this is 1 millimeter steel plate. You can buy this in many, many locations. People use it to make all sorts of things. People use it to make, there's a local industry of highly experienced welders and metal workers. It's also using galvanized steel wire, which is used a lot in construction. You can buy this easily. It's got a good price, got a low price, and you can many people know how to work with it. And all of this was put together using locally available cutting tools and welding tools. So there was no special tools that we needed. These are tools that local metal workers already have to hand, and they know how to work with this kind of stuff. So really, those were the three key criteria. It can be operated manually or with locally available power sources. It can be collapsible to not take up a lot of space on a truck, and it can be made and maintained with locally available low-cost materials.